Alright, so let's review. One of the things about solving equations is it takes a lot of experience. We're using inverse operations, which is SADMAP, right? Sometimes, like with some situations like these problems, you have to do some simplification. Then you're using PEMDAS. Sometimes it's hard to know which one to do first. They won't be mathematically wrong one way or another as long as you're doing them correctly. But sometimes if you do one step first versus another, it makes the problem really easy. Or sometimes you take a problem and you make it really difficult. The only way you know the difference, Adon, is really experience. So I created these 5 problems. Well, 4 of the 5 are to help you get that experience, right? So two things about these kinds of problems that I want you to be thinking about. You want, if there's more than one x, like in this one, you want to get those x's together as fast as you can before you start making other decisions on what to do. That's a general guideline that really will serve you well with all kinds of equations, especially like when there's x's on each side of the equal sign, right? And then with stuff like this, you could do 2 things here. You could distribute 3/4, or you could multiply by the reciprocal, right? And then, well, here's the thing, Anna. If you have a choice of steps to take, if one step will get the fractions gone, do that, because then it's simpler, right? Alright, so here we go. We're going to keep these 2 things in mind as we do these. You ready, Johnny? Alright, Johnny. First one. So I could distribute and I would get 3/4 x plus 9/2. I don't want to do that. I'd rather not have a fraction. If I multiplied both sides by 4/3, do you see that 12 and 4/3 would reduce? Do you see what I'm talking about? So that's what I'm going to do. I'm going to multiply both sides by 4/3. That equals what? 1. So I'm left with x plus 6 equals, what's this equal? 16. You were going to reduce, right? 3 goes into 12 4 times. 4 times 4 is 16, so you're done. Good? Okay. Well, freshmen are getting shorter and shorter. You see that freshman in the hall? You didn't see that, Tristan? There was a little, like, a 2 or 3-year-old kid walking with I don't know who. Right. Okay, so this says what number plus 6 is 16, so that's 10, right? Okay. If we wanted to check this, we could. 10 plus, like x is 10, right? 10 plus 6 is 16. 3/4 of 16, like you could reduce, right? That's 12. We're good. That's the right answer. Are we doing all right? Okay. Yeah, Nelly, we're doing good? Okay, number 2. Man, you know, there's a shortcut. I could actually multiply every single term by 8 and have no more fractions. Well, this is like, what's this evil you're talking about? This is voodoo. Check this out. This is a trick I know you guys don't know, but I'm about to show you. You ready? Eduardo, check this out, buddy. I'm going to multiply everything by 8. 8. Every single term. So I'm going to put a big bracket around the entire equation. I'm going to multiply every single term by 8. The tricky thing here, August, is you got to make sure you multiply every term. But you don't want to multiply one term twice. Like this is one number. Like this is all one term right here. So I'm going to multiply that whole thing by 8. I'm going to multiply this by 8. I'm going to multiply that by 8. Yeah, weird, right? Here's where you're going to get in trouble. People are going to do, when you do multiply this one right here, here's what people are going to do. They're going to say this is 3 times 16x plus 8, and that would be wrong. It's just going to be 3 times 2x plus 1. It's going to be 3 times 2x plus 1. Now the reason that is, like, it gets confusing when you have binomials and fractions and stuff. But watch. 2 times 3 times 4. Is that 6 times 8? 2 times 3 times 4. Is that 6 times 8 or is it 6 times 4? Or is it 3 times 8? 2 times 3 times 4. Is it 6 times 8? 6 times 4 or is it 3 times 8? You think it's 6 times 4? What about this one? What's that? Oh, you think it's all of them? Well, this one's 24 and this one's 24, but that one's 48. That one's not right. You don't multiply 2 times you don't multiply 2 times 3 and 2 times 4. Right? That's multiplying 2 2's. You're only multiplying with 1 2. Same thing happens right here. This is 8. Now you're going to multiply it by this one, because the reason you multiplied by 8 is because of the denominator of 8, right? And those reduce. Anna, you spaced out. Okay. What about this one? What's that going to equal? 2x. Good? Equals, don't forget here, 48. Dang. Adon, did you know that trick before? It's pretty cool, huh? Is it mathematically true? Did I do everything the same on both sides? Multiplied everything on both sides by 8. Yes, ma'am. You tell me. That's a really good question. Why did I multiply by 8? Why did I pick 8? Huh. Melody, do you know why I picked 8? Because of what? Yeah, but why 8? It is, that's true, but also 4 goes into it. Don, why did I pick 8?
Well, because 3 8s, 8 over 1 is 3 over 8 can cancel each other, just 3. And 1/4 we can just go with 2. And 8 6 is 48. So like it's easy.
You're right. I picked 8 because 8 is the lowest common multiple of the denominators. Yeah. Okay. So now I just have to distribute and combine like terms, right? 6x plus 3 plus 2x equals 18. So is that 8x equals 15? So x equals 15 over 8. Yeah? Oh my gosh! I just didn't write it correctly. I don't know where I got 18. That's weird. It's Thursday morning. That's where I got 18. Alright, Laura, that's a cool trick. That's a cool thing right there. Now, could you get the answer, this answer, without doing that? Yeah, you would just distribute and combine like terms just like before, except you'd have, you know, fractions. Do you want me to do it the hard way too? No. Whoa. Wow, that was pretty emphatic no. Okay, we won't. All right, this one. The tricky thing about this one is this is -1 times 8 minus 6x. That's why this one's tricky. Yes, ma'am.
Wasn't that a plus 6x?
Wait, what?
Yeah. Like the other one, wasn't it 8x minus parentheses 8 plus 6x?
Oh, was it plus 6x?
Yeah.
Okay, would that make you happy?
Yeah.
Okay. All right, let's do that one then. So that's a little simpler because I don't have to worry about a negative times a negative, right? But this one is tricky still for the same reason. That's really -1 times 8 plus 6x. That's what that's tricky. So this is going to be 8x minus 8 minus 6x equals 2. 0. 20. Okay, so 2x equals 28. Is that okay? Because I'm going to combine like terms. Do not do this. I'm going to write this and it's wrong, okay? It's wrong. Do not do this. Do not add 6x like that. That's ridiculous. You know why that's ridiculous? Because I added 12x to one side of the equal sign and then did not add anything to the other. You see that? I added, this is 12x on the left side of the equal sign. I didn't add anything on the right side of the equal sign. That's not adding the same thing to both sides. You can change the order when you add and subtract. Commutative property. Right? 3 plus 4 is the same as 4 plus 3, right? You can change the order around. No big deal. I know that you guys do this. Yeah. You know what they used to do when I was in school? If you did that, they'd rip your fingernails out. Yep. True story. Okay, so x is 14, right? X equals 14. So we're good? This one says 4 times what plus 50 plus 5 is 33. I think it's 7. Right? Like not even doing the steps. Like, this is what I don't know, right? So what plus 5 is 33? What plus 5 is 33? That would be 28, right? So this thing I covered up with my finger has to equal 28, right? So 4 times what is 28? 7. Yeah? We good with that one? Okay. This one's tricky because of the negative sign. Negative x plus 5. Why is it plus 5? Yes, sir?
Because the negative is a negative opposite.
That's right. It's really negative 1, right? Plus 2x equals 6. So is this... Oh, man. Now here... Oh, my gosh. You guys are going to... Oh. You can just rearrange these. Those make 1x. This is really x plus 5 equals 6, so x equals 1. Yeah? Yeah? You got that, Johnny? Dang, Johnny. Johnny, you're okay. I don't care what Edgar says. You're all right. Right, Edgar?